We've got a spinner with edges 1, 2, 3, 4. It's spun, and the probability is given by this distribution here. But we are asked to put this information into a table. So I've got x, and then it can be 1, 2, 3, or 4. Okay, I could have 5, 6, 7, but then we're told the probability is 0, so there's no need to put that into the table. And then the probability that capital X is equal to this little x. So x is the values it can take. Capital X is actually the random variable itself. So when x is 1, or remember, a half is actually 5 over 10. So when x is 1, it's just 5 over 10 minus 1 over 10. It's going to be 4 over 10. And then it's going to be 5 over 10 minus 2 over 10. And it's just going to go down by 1 every time. So when it's 4, it's going to be 5 over 10 minus 4 over 10. So that is our table. It's a little bit easier to read, but it's not as concise as the probability function. Now we're told the spinner is spun 3 times and the value of x is noted each time. Find the probability that the third value of x is greater than the sum of the first two values of x. All right, well, there's a really quick way of doing this question, and it's just to think about the different arrangements you can have such that this is true. So we need the third value to be bigger than the sum. So I'm just going to start off and work systematically through this. So the smallest it could be for the first two values would be 1 and 1, which would give me a sum of 2. So I could have the third value greater than this if I make it 3 or if I make it 4. So I'm going to write both of those down. Okay, that's the only possibilities I can get with 1 and 1, and then the third value being bigger. But I could have 1 and 2. That would be the next one up. So then the sum would be 3. So I can't put a 3 here now, but I can put a 4. That would be an option. But I could instead get 2 and 1. But then I'm done because the next one up would be 2 and 2 or 3 and 1, and that would equal 4. So I can't have the third value greater. Okay, so these are essentially the different paths along a tree diagram. And you don't want to draw this tree diagram out. It's going to be, we'll kind of just sketch it over here, but it's going to be, 1, 2, 3, 4, and then you're going to do these branches going off. You can see that when you actually, although the idea of a tree diagram is great, especially when you're introducing this kind of thing, you don't actually want to use it for, it's going to be 4 times 4 times 4, 64 different little branches going on here. But we can use the idea of a tree diagram because for me to get 1 and then 1 and then 3, I would multiply those probabilities together. So it's going to be 4 over 10 times 4 over 10 times 2 over 10. Sorry, that was meant to say 3 there. Okay, that's actually what you'll do to get this path here. This probability times this probability times this probability. So I've drawn a tree diagram because it can kind of still give some instruction. And here it's going to be 4 over 10 times 4 over 10 times 1 over 10. And then it changes up a bit. It's 4 over 10 times 3 over 10 times 1 over 10. And this is actually exactly the same. It's just I have to swap these two around, but I will actually get the same answer. Okay, so let's work out these answers. Actually, I'm doing all this without a calculator, but you can obviously use a calculator, but sometimes it's easier to not. 4 times 4 is 16, times 2, 32. And 10 times 10 times 10 is just 1,000. So all of these are going to be over 1,000. This one's 16 over 1,000. And these two are both 12 over 1,000. Sometimes in questions, like when you get the same thing but just arranged differently, it's better to actually calculate one and then times by how many times it's being rearranged. So I could have just times this by 2, but I'm not really saving much time here. And if I add all these up, well, 12 plus 12 is 24. If I add that to 16, 40. 40 plus 32 is 72. So the answer is going to be 72 over 1,000. You could simplify your answer, you could write it as a decimal, but actually in probability questions, it's accepted that you don't have to simplify it. So that is my final answer. I'm just gonna say this is the probability. I'm not gonna write the whole thing out, just probability required. Okay, nice end to this paper. I like these sorts of questions, and it's not too bad if you've done enough on tree diagrams and got your head around it, okay? But you don't want to be drawing this tree diagram. Try and move away from it and understand why you can essentially use the tools of a tree diagram, but just away from it, just look at the actual possibilities that you're interested in. Thanks.